Hello, ladies and gentlemen. Today, what we're going to do is we're going to take a look at density. We're going to do a 2 week study on reviewing and revisiting density as we end up this as we finish up this semester. Okay, so let's take a look. Alexander, Riccardo, usually do 898, so why not? In the last chapter, you looked at heating and cooling. Well, this is chapter 3. We just did chapter 6. So we're basically going to take a look at a characteristic property of matter that is density. Okay. And we're going to watch a video comparing the mass of aluminum and copper cubes.
Let's take a look at two cubes that are the same size but made of different materials. The cube on the left is made of aluminum and the cube on the right is copper. The copper cube is clearly heavier than the aluminum cube. Now let's put the cubes on the electronic balance and determine their mass. The aluminum cube is 43.0 grams. The copper cube is 137.4 grams, over 3 times as massive. And remember, these cubes are the same size.
All right, so which one is greater? Copper. What is the mass of the copper? Into the number of grams below, 137.4. What is the mass of the 43.0? Density is a measure of the volume of a certain volume of a substance. Measure of the mass of a certain volume of substance. Since the cubes are exactly the same volume and the copper has more mass, which substance do you think has the higher density, copper or aluminum? We go copper. Because it weighs more. It weighs more. Copper is 137.4, aluminum is 43.0. It's 3 times as much mass, and so its density has more is more dense than aluminum. How can you calculate the density of a cube? Okay.
Together, we'll find the density of a cube. Density is defined as mass divided by volume. So we'll need to know the volume of the cube. Volume is length times width times height. For a cube, length, width, and height are all the same value. The cubes we're using are 2.5 centimeters on each side. So the volume is 2.5 centimeters times 2.5 centimeters times 2.5 centimeters, or 15.6 cubic centimeters. Now that we have the volume, we need to determine the mass. To find the mass of the cube, we'll put the cube on the electronic balance. This cube has a mass of 78 grams. Now we can calculate the density. The density of the cube is m divided by v, mass divided by volume. The mass of the cube was 78 grams from the electronic balance, and the volume was 15.6 cubic centimeters. So the density of this cube is 5 grams per cubic centimeter.
In the first video, you found that the copper was 137.4 grams. Use this mass and the volume of the cube to figure out the density of the copper cube. All right, you find it at all right, so how's the mass of the cube to figure out? You go, was it 15.6? Okay, so you would go 137, you would go calculator, right? 137.4 divided by, sorry, 130, 137.4 divided by 15.6. Get you 8.8. So you're going to go 8.81 grams per cubic centimeter. In the first video, you found that the aluminum was 43 grams. Use the mass and the volume of the cube to figure out the density of the aluminum cube. So you're going to go back up here. All right, you to retry it, and you're going to go 43.0. Sorry, doesn't allow me to do it. 43.0. I love this. Hit the wrong button. Divided by 15.6, you're going to get 2.76, 2.8 maybe, 2.76. Okay. The density is 881 and 276. Very good. Okay. Look at the diagram below. Describe a few differences between the copper and the aluminum. See what you can see. Copper is smaller, aluminum is bigger, right? Copper atoms are heavier than aluminum atoms. Coppers are slightly smaller than aluminum atoms. Since the density of a substance depends on the size, mass, and density between its atoms, every substance has its own unique or characteristic density. In fact, you can identify an unknown substance if you can find its density and then compare it to the densities of known substances and find its match. We'll do that in the next activity. All right, I'm sorry. Look at the diagram. Describe a few differences. Oh, okay. Well, like it said, smaller. Copper is smaller. Um, and more abundant than aluminum, which are bigger and more spaced out. Okay, so all right, copy this table into your notebook. You will receive instructions on how to complete the table in the video and questions that below. All right, so in my notebook, I'm going to go real quick with it. We go A, B, C, D, E, F, G, H. All right. 15.6. Okay, so sample volume in centimeters cubed, mass in grams, density, grams per centimeter cubed, and then you're going to go material. All right. So you got 15.6 all the way down. Mass 43.0 for A, 137.4 for C. That's a density of 2.8 and a density of 8.0 or 8.8. That's aluminum, Al, and copper, Cu. I'm going to turn on my camera and you can see that right there. All right. It's basically exactly what it says. All right. Again, it only took me about a minute to do. All right. So now we're going to watch it. You're going to go A, B, C, D, E, F, G with it, and then we're going to probably determine what they all are. All right. Let's go.
We're going to do an activity together. You can see here that we have 8 cubes. The cubes are all the same size and are 15.6 cubic centimeters. The cubes are labeled A through H. Each cube is made of a different material. We will use the electronic balance to determine the mass of each cube. I need you to get a piece of paper to write down the mass of each cube. Alternatively, you can open up a document in your computer and type up the masses. Right now is a good time to get a piece of paper or open a document and label it A through H and leave space to write the mass in grams of each cube. Pause your video.
You can do that right like this. Just go Google Docs. Let's see, you open up. Actually, go Sheets, makes it easier, right? You could also go to your apps, go to Sheets. And again, you're doing the same exact thing as before, right? Yeah, so it's just taking a while, that's all. Sample, volume, hold on a sec. That would be volume in cubic centimeters. There's that cubic button there. All right, mass in grams, density in grams per cubic centimeter equals, and then you would go material. All right, you would go A, B, C. You highlight these three and then drag it down. Nope, it didn't do it for me. See if I do it this way. Nope, I didn't do that either. Used to be you could do that. C, D, E, F, G, H, H. All right, this is 15.6. Again, take this corner, drag it down. It's all the same. All right, this one is, or I'm sorry, 43.0. And this one is 137.4. All right, now I'm going to give you a little bit of a hint, a little bit of a thingy. All right, here we go, equals, divide. All right, you go this number divided by that number, and then you close it. Why didn't that work? Oh, I'm sorry, comma. All right, this number divided by that number, you press enter, it's going to give you the answer. You go down like that, and it's going to give you the answers for all of them. All right, so all you got to do is get the mass number. All right, but I didn't show you that. All right, aluminum and copper. Now I'm going to put in all my work in the what do you want to call it? In my notebook, but then I'm going to come back to this afterwards. All right.
Video until you're ready to begin. Now let's record the mass of each cube. Cube A. Cube B. Cube C. Cube D. Cube E. Cube F. Cube G. And finally, cube H.
All right. So before it tells me to do anything, what I'm going to do is I'm going to go back. I could do every single one of these. All right. So I got 15, 15.6. Everything is divided by 15.6, right? So it's 130.6 divided by 15.6. All right. So it's 8.4. Okay. And that would go for B. And then 121.0 divided by 15.6. That'd be 7.5, 7.75, 7.76 for D. And so on and so on and so on, right? Now remember, this one over here, I'm just going to plug in the numbers based on what she said. 136, 121.1.0, 22.1. It was 22.0 and then it went to 22.1. So I'm going to go with 22.1. 18.3 and 12.1 and 7.6. All right. So I'm going to go in and plug in my numbers as I see it. 4, 837 is 8.4, 776. So that would be 7.8, 1.4, 1.2, zero point 0.8, and 0.5. Okay. So those are the numbers that I'm going with. Now, if they don't like that, then you can come back with 837, 880, 7.76, 1.42, 1.77, 1.17, 0, 0.78, and 0.49. All right. But I'm not a stickler for the numbers. This is basic, basic elementary physics. And I don't mean elementary as in elementary school. I mean like a classical elementary physics. All right. Which cube has a mass of 121? That was D. All right. Do the numbers on that. Which one had a density of 1.17? All right. So that was F, I'm going to say. F. So they were going with the three significant figures. So you would go with F, all right? So they're a stickler for the numbers. I'm not. It's all right. All right, match them up with what they were. All right, brass is 8.4. Brass. 7.8 is steel. I'm guessing it's going down in order. Yes, it is going down in order. 1.4 is PVC pipe. Nylon is 1.2. Oak, it's wood. 7.9, 7 to 9, 0.9, and pine or poplar. Okay, it's cool. All right, which is made out of oak? It's G. Brass would be B. Yeah. There are 4 metals, 2 plastics, and 2 woods. If you look at the materials of metals, plastics, and woods, how would you rank from the most to the least? Metal, plastic, wood. Metal, plastic, wood. There you go. So yeah, it's like that. Yeah, it's good. Most common things, most metals are less dense, and then woods. Yep. All right. What are 2 main reasons why most metals are more dense than uh, plastic and wood? Well, there's a space in between them. Um, there's obvious space in between, and what's the other one? Boom, 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 more dense because they're heavier molecules. Um, so the arrangement between the different metals is usually based on the size and the mass of the atoms, but the arrangement of the atoms in most metals is pretty similar. So the arrangement, let's see, are less dense because they can be similar density to wood. Um, so one of the 2 reasons why I'm more dense, similar arrangement, more more mass per molecule, um, less space between um, the molecules. Yeah. And then you would read that there. They're closer together, right? Less space, tend to be heavier. Yeah, cool. And that's it. That's it's relatively simple. It's relatively fast. There's a couple of numbers that you got to crunch in there, but yeah, use a spreadsheet. Makes your life a lot easier. Also, you might want to take a look at a density calculator. All right, density calculator. Omni is really good. Omni works really well. What you got to do is you got to set it up the way that it's supposed to be. So this is grams per centimeter cubed. You want to make sure it's um, cubic centimeters. You want to put in grams. All right. So you would go with, say you would go, your volume is 15.6, and then your mass is 43, and it would calculate it. And it's 2.76, and it shows you how to do it. So if you had to write it down on a paper, it would show you how to write it down. And that's exactly how you would do it. P is density, lowercase p equals m over v. So that's 43 grams divided by 15.6 cubic centimeters, 2.76 grams per cubic centimeter. You would write it out exactly like this. I would expect this right here to be your answer of what you were about to write down, right? Um, and then, like I said, Omni is a great calculator. Um, you would go density calculator, and then you would go to the Omni one, which is the third one. Throughout the course of this semester and next semester, when we're doing physics, we will be using the Omni calculators a lot. Again, grams per centimeter cubed. So it would be 43 grams, 15.6, and it gives you the answer. Now, this one doesn't do the math for you, but remember, I'm sorry, it doesn't show the math for you. Um, but if you're not asking for the math, most of the times they don't ask for the math, it gets relatively easy. Okay. So with that, it should be a relatively easy activity, and have fun with it. Okay. Bye.